we have seen the interrupts. Then also we have seen some of the what we can say. So we have seen the different interrupts which are available with the microcontroller, in which the first interrupt which is available in the microcontroller is reset. That is the first interrupt. And after reset, we have seen two external hardware interrupts and two timer interrupts. So there are timer interrupts. So these are two interrupts. Reset is one. Then we have seen the external interrupt. So external interrupt. These are two external interrupts, and also we have seen one serial interrupt. So there are six interrupts available with the microcontroller. One is reset, then two timer interrupts, then two external interrupts and serial interrupt. Okay, so the timer interrupts are timer 0 interrupt and timer 1 interrupt. The external interrupts are external interrupt 0 and external interrupt 1, and the last one is serial interrupt. Now, with all these interrupts which are available with the microcontroller, we have seen that all these interrupts are enabled and disabled by the register IE. So the D7th bit of this IE is enable all. So all interrupts are getting enabled when the D7 bit is 1. Otherwise, the bit when this bit is 0, all the interrupts are disabled. After that, D6 and D5, these are not used. D5, it is timer 2 interrupt, which is available with microcontroller 8052. But for microcontroller 8051, this timer 2 interrupt is not available. Then after that, we have seen the remaining bits D4 to D0. All these bits are provided to the timer interrupts, then external interrupts and serial interrupt. Okay, so D4 to D0, all these bits are provided to the different interrupts. So when these bits are 1, then the particular interrupt is getting enabled. If this bit is 0, then the particular interrupt will get disabled. Okay, so we have seen all this in the last lecture. Now we will move towards the next part, that is the programming of interrupt. Now, first we will see how to program the interrupt, or how we will use interrupt for the function of timers. Okay, so initially in this timer interrupts, what we have seen, when we are writing the program for timer interrupt, first we need to set the tmod register. Okay, so here in this tmod register, what we are doing, we are selecting the timer, either timer 1 or 0. And after that, also we have seen the mode of operation of the timer. That means mode 0, mode 1, or mode 2. It depends upon in which mode we are using that specific timer. Here, we are setting it with the tmod tmod register. Okay, and with this tmod register, also we have two more registers. One is THX register and TLX register. So here we are setting the count into this TH and TL register. These two registers are called as count register. Okay, so we are using this count register to set a specific count into that registers, so that whatever the delay which we need to add into this particular timer program, that will get provided using this count register. Okay, and after that, we are starting the timer with the setting of TR bit. So for timer 0, it is TR0, and for timer 1, it is TR1. So we are setting this, or we are starting the timer with the this TR bit. Okay, so we are starting it. Then we are waiting unless and until the timer flag is set. If it is timer 0, TF0 flag, and if it is timer 1, then TF1. So whether this particular timer flags is set, then the particular timer, we are stopping it, and we are again resetting the timer. Okay, so we are checking this TF0 status, and we are waiting or keeping the program counter into the loop mode by just writing back or by giving the label to the same TF0 bit. Okay, and when TF is set, we are clearing TR0 and TR, and we are clearing TF for the next time count. Okay, which we are resetting, and again after that we are again setting th and tl count, and again we are doing the program. Okay, so this is the complete function which we are doing during this timer programming. So in this timer programming, we are checking the status of tf0. So here what we are doing, we are keeping the program into the loop mode. Okay, so we have already seen the difference between the loop and interrupt. So if it is in the loop mode, unless and until this tf is set, the time program counter or the microcontroller will get engaged to check the status of this tf0 bit only or tf bit only. Okay, so if the microcontroller wish to work do any other work, that also cannot be done because the program counter remains into the loop here only at this particular location only. Okay, that's why in spite of checking the status here, we can use interrupt for this particular operation. Okay, and we will see how we can use the interrupts or timer zero interrupts for the specific program.
Hello, sir.
Yes.
Hello, sir.
Yes.
Screen is not visible.
Yes, what is the problem?
It's not visible.
A screen is not visible. Okay.
Screen is visible, sir.
Okay, just I'm making it visible. Is it visible now? Hello? Screen is visible now? Hello?
No, sir.
No, sir, not visible.
Not visible. Okay. Just I will make it again. Now is it visible? Hello?
Yes, sir, visible.
Yes, sir, it is visible.
Okay. So what we're seeing, so we have started with the timers, right? Just 1 minute. Okay. So we have seen the interrupts. So there are 6 interrupts. What is the problem here now? So we are started with the interrupts. Okay, so there are 6 interrupts in which one is reset, then timer interrupts. So there are 2 timer interrupts. Then we have seen the external interrupt. So 2 external interrupts are available, and one is serial interrupt. So all these interrupts together are available with 8051. Now also we have seen all these interrupts are enabled and disabled by the register IE. So the D7th bit is enable all. So if this bit is 1, then in all the interrupts are enabled. If this bit is 0, then all the interrupts are disabled. Then for D6 and D5, these 2 bits are not used for 8051. The D5 bit is for timer 2, which is used into the 8052 microcontroller. Okay, so this is for timer 2 interrupt. Then D4 to D0, these 5 interrupts or bits are used for enabling timer, enabling all the interrupts or disabling the interrupts. Okay. Then we have seen that for all these interrupts, we can use for different operations. So here for microcontroller, if suppose we are using timer interrupts, okay, So for timer interrupts, we will see the use of these interrupts. Okay. Now, previously we have seen the program where we are using timer to provide the delay. Okay. And for that purpose, we are using tmod register to set the timer as well as to set the mode of operation of timer. Okay. So either if you want to use timer 0 or timer 1, and at the same time, in which mode we need to use that particular timer, that is decided by the tmod register. Okay. After that, we are using thx and tlx, these two as a count register. So whatever the count required for delay, that will get provided into this thx and tlx. Okay. After that, the next bit which we are seeing is trx bit. So for timer 0, it is tr0, and for timer 1, it is tr1. So this bit is set to start the timer. And after that, we are checking the status of TFX bit. That means for timer 0, TF0 bit, and for timer 1, TF1 bit. So we are keeping the controller into the loop, okay, unless and until this TFX is set. Okay. And after that, we are clearing timer TR0 or timer TR1, as well as we are clearing TF0 or TF1. Okay. So here, unless and until this TFX is set, here we are keeping the program into the loop, or the microcontroller is kept into the loop unless and until this TF is set. Okay. So here we are using the format of looping. Okay. So here in this case, if suppose microcontroller want to do any other work, that also cannot be done because the microcontroller is in the loop mode. So it will check the status of TF bit only. So in spite of that, here we can use the interrupts. Okay. And which interrupt here we can use? We can use timer interrupts. Okay. So if this program is for timer 0, we can use timer 0 interrupt. And if we are using timer 1, then we can use timer 1 interrupt. Okay. So for that purpose, we will write the program. Okay. Now, here what we will do, we will generate a square wave of 10 kilohertz. Okay. So assume the square wave of 10 kilohertz at a particular port pin, let's say port 1.1. This is the port pin where we want to generate a square wave of 10 kilohertz. And here we will use interrupt for the same. Okay. So what we will do here, we will use timer 0. Here I am giving one example only, timer 0 mode 2. Okay. So this mode 2, it is auto reload mode. Okay. And we need to use timer 0. So by using timer 0, here we need to generate a square wave of 10 kilohertz, as well as we need to consider the timer interrupt also. Okay. So here what we need to do, first we need to set the tmod. Okay. So if we set the tmod register with timer 0, here what will be the bits available? First 4 bits are for timer 1. So these 4 bits are 0, 0, 0, 0. Then the next 4 bits are for timer 0. So here gate will be 0, C oblique T bar will be 0. Then for mode 2, the bits are 1, 0. So it is 0 to H. That will be for tmod. Okay. Then the next is we need to set the count into the TH register. Why only TH register? Because when we are using auto reload mode, then whatever the count which is available into the TH, the same count will be available in TL also. Okay. And the count in the TL is getting overflow. Okay. So whatever the count which we need to store into the auto reload mode, that count is loaded into this TH0 only. Okay. So to set the count here, we need to consider the frequency of the microcontroller. So let's assume 22 kilohertz is the frequency of microcontroller. So from this 22 kilohertz, here what we need to do, we need to first divide that the frequency by 12. then we can use it for timer. So this 22 kilohertz will get first divided by 12, and what will be the result? Anyone can tell the result? Hello? Am I audible? Just turn on the mic and tell me the result. What will be the result?
1.83, sir.
1.83, right?
83.
1.83, just a minute. Okay. So here the result will be 1.83. Sorry, here I have done one mistake. It is 22 megahertz, na? I have written my kilohertz, sorry. So it is 1.83 megahertz. That will be the frequency. Now, we require the actual square wave of 10 kilohertz. Okay, so here what we need to do? The desired frequency is 10 kilohertz and available frequency is 1.83. Now here what we need to do? Already we have seen in the timers. Anyone? So here the desired frequency, whatever is available, will get divided with the available frequency. Okay, so here it will be 10 kilohertz divided by 1.83 megahertz. What is the result? Anyone? Just turn on mic and tell me the result. Hello, am I audible? अरे कोणीतरी सांगा रे.
Yes, sir, audible.
हाँ, अरे मग रिझल्ट सांगा ना मला. ओनली डिव्हिजन यू नीड टू डू.
5.46 milli.
5.46
46
kilo.
into
That
10
means
raised
it
to
is
minus 3.
into 10th power minus 3. So this is
Minus 3.
This is the frequency, right? So here we need to convert it into the time. Okay, so we need to divide it with, or sorry, so for time here what we need to do, we need to divide, it is inversely proportional to the frequency, so it is equal to 1 divided by 5.46 into 10th power minus 3. So what will be the result here? काय येणार result?
183.
183. 183. Okay, so this is the count which we need to subtract from the maximum count for single racer or 8-bit racer. It is 256. So 256 minus 183. The result will be किती येणार result? 256 minus
73.
183. So it is 73. Now when we convert this 73 into hex, then what will be the result? I think something B6 or something असं काहीतरी येतो का? Am I right? Result हाच आहे का? Anyone? Okay, let's assume it as B6. Okay, now here we have what we have done. We have set the T mod as 0 to H. Then TH count will be B6H. Now we will write the program. Okay. So here the first instruction will be ORG 0000H. Okay. Now see here, in the previous lecture, what I have told you, whenever we are using the interrupts, these interrupts are having vectored location. And these vectored locations are starting from 0000 onwards. Okay. And after that, for every location, we have different ISRs. So for timer 0, we have ISR at the location 000B. Okay. Before that, we have external interrupt, which is having the location 0003, 0008. Right. So this is the location, ISR locations which are provided for the different interrupts or ISR location. So for timer 0, we have 000B location. So here what we need to do, while writing the program, here we need to jump from this location to the next location. We will write it as ljump main, and main will come somewhere in the main other program. Okay. And here at this particular ISR, we need to write the operation of complementing. Okay, so here we will jump here. Now, here we will initiate, or we will write the ISR of the timer 0. So we need to again initiate the location at 000B location. Okay, and after initiating that location here, what we need to do, we need to we will complement port pin, port 1.1, I think. This is port 1.1, right? So here we will complement port 1.1, and after that we will return from main program. Okay, so this is the ISR of the interrupt timer 0. Okay, here only what we have done in the ISR, we have just complemented the port pin, and again to return back to the main program, here we have written as with return from the interrupt, that is RETI. Okay, now we will move towards the main program. Now here for the main program, we will start somewhere with the location 0030H. Okay, this will be the location of the program. Okay. And at this location, we will jump from the main program. Okay, so this is the main program. So from this main program, we have jumped to this location, and within that, if the interrupt is generated, the program counter will jump to this ISR location, and it will execute the ISR, and after that, it will return back to the main program. Okay, so here we will come to the main location. Okay. Just to give me the time. So here, first is ORG 0000H, then ljump main. Okay. And after ljump main, here we have written the program for ISR at the location 000BH. Okay. And here only we have complemented port 1.1, and we have returned from the main program. Okay. Now we will write the program somewhere at the location 0030H. Now here we will come to the main location. Okay. Now here what we need to do, here we will write the actual program move tmod, hash 0 to H. Okay, this is the initiation for timer. Then the next will be move th0, hash 0 b6h. Okay, this is the count which we have set for timer. Now see here, again we need to set the interrupt enable register with the instruction move IE, hash. Now what will be the count here? Now already we have seen that IE register, the D7th bit is interrupt enable bit, EA bit. So the D7th bit is 1. Then after D7th bit, the 2 bits are not used. So we will write it as 0, 0. Then the next will be for external interrupt, the bit will be 0. Then for timer interrupt, the bit will be 1. Then for other interrupts, keep it as 0, 0, 0 something. Okay, am I right? So here it is enable all interrupt. These two are not used into the program. Then the next bits are, sorry, here I have done the mistake. It is for serial communication. Then for timer 1, sorry, external interrupt 0 and 1, then it is for timer 0 and it is for timer 1. So here the count will be 8 and 2. Okay, so this is the count which we need to load into the IE register. So here the count will be 8 to H. Okay, so either you can set the count into the IE register or directly you can write here as with the instruction set B IE dot 7. Okay, that is enable all interrupt, and after that you can write set B IE dot 1 for timer 0. Okay, so you can use, in spite of setting the count into the IE register, you can also set the particular bits by using Boolean instructions, that is set B or clear B. Okay, so either you can set a specific bit or you can use the IE register. So here, for the sake of simplicity, we have taken IE comma hash 82H. Okay, now here only the thing is we need to start the timer set B TR0. So the timer will get started, and after starting the timer, here only we will write a simple instruction as jump back. Okay, and that back we will again give to the right, it is auto reload, no? So here we will give the back. Okay, and the last one will be end. Now see here, in this program we have started the timer, and here we are not checking the status of TF0. So when the TF0 is set, automatically that particular bit is gets cleared when the program counter is getting shifted to the from here, when the program counter is shifted to the ISR location. Okay, so at that time the TF0 will automatically get cleared, and again it will return back. It will execute the ISR, and again it will return back to the main program. So it will execute the next instruction now, that is jump back, and it will remain in the loop. Okay, so everybody understood it? Here what we have done, in spite of keeping the loop at TF0, we have discarded that loop by using the interrupts or timer 0 interrupts. Okay, so everyone understood it? Everyone understood the program? Okay, now we will write the same program here. I will stop this program. Is screen visible to everyone? Just turn on mic because I'm not able to see chat window. Will write org.
Yes, sir, it is visible.
Pardon?
Yes, sir, it is visible.
Okay, okay. So org 0000H. Okay, then the next instruction is ljump main. Okay, we are giving the main somewhere in the program because we need to skip the location or the loops for ISRs which are available into the microcontroller. Okay, then we will write org 000BH. Okay, so 000BH, that is the location for ISR of timer 0. That's why we need to initiate that location, and here we will write the instruction or ISR as complement of port 1.1. Okay, only we are complementing the port pin. Okay, and then we will return to from the interrupt. Now we will write the program here for timer. So we will start with 00030H. Then we will write the main. Okay. So what was the program? Move tmod, comma, hash 20H for setting the timer 0 in mode 2 operation. Then move th0, comma, hash 0 b6h. That is the count which is loaded into the timer th0 register. Okay, then we'll write the instruction move ie, comma, hash 82h. Okay, to enable the interrupt as well as to enable timer 0. Okay, then here after setting it only we have started the timer with set b tr0. Okay, and then we have kept the program into the loop with a jump back. That back is given to this IE because we need to reset the IE. However, this auto, as it is in the auto reload mode, TS0 is already getting set. Okay. And after that, we will write the end. Now see here in this program, we have not set or we have not used the TF0 bit, which is overflow bit. Okay. So once it is overflow, it will generate the interrupt and automatically it will jump or the program counter will jump to the particular ISR location. Okay. So this is the program. We'll save this program with timer 0 interrupt with ASM. We will add the program. Timer 0 interrupt add. So there are 0 errors. Now we will run the program. Okay, now see here, we are checking port 1.1. Okay, so here we will use this port 1. This is the interrupt structure. Now see here, in this interrupt system, already you can identify that INT0 is having the location 003H. This is the vectored location. For timer 0, 000B. For interrupt, external interrupt 1, 0013. Then for timer 1, 001B. Then for serial interrupt 0023. So that's why in this program, we have initiated the timer at 000B. Sorry, ISR, we have initiated ISR at 000B. Okay, so where the ISR is available for timer 0. Okay, now in the logic analyzer, we'll take it separately and we will set the logic analyzer here. It is port 1.1. Okay. Now we will run the program. Now you can see we get this square wave here. Okay. And see it is, now see in this program here, timer 0 interrupt is enabled. Here you can check it here, as well as external interrupt, all interrupts are enabled by setting enable all bit. Okay, so which are the interrupts which are getting selected or enabled, that will be, we can check here, and at the same time all the when we enable all interrupts, that will we can see at this particular EA bit. Okay, so here we are getting square wave at port 1.1 when the interrupt is getting generated. So once the interrupt is getting generated, the port will get shifted from 0 bit to 1 bit and vice versa from 1 to 0 once the interrupt is generated. Okay, so here in spite of using TF0 or the timer flag, and also we need not require to clear the TF0 bit as well as TR0 bit. Okay, directly we can use interrupt and we can generate the square wave here. Okay, so this is the square wave. Everyone understood it? Okay, now here in this program we have generated a one square wave. If suppose we need to generate two square waves, okay, using the same operation, here in this main program only we will make some sort of changes. Now see here, for timer 0, here we have complemented port 1.1. Also we will complement port 2.1 also. Okay, so here if we are doing this function, then we will get two separate square wave at two different port pins only by using one timer and one interrupt. Okay, now in the same case, here if suppose we want to generate two square wave of two different frequencies, in that case here what we need to do, we need to set the count into that specific registers, and for two different frequencies we need to use two different timers, timer 0 and timer 1. So in that case also, here only we will set the this tmod and th registers into the ISR location, and in the main program only we will start the timer. Okay, so here in the main program what we will do, or we can use two different timer interrupts also. If suppose for one square wave we have used the timer 0 interrupt, for second square wave we can use the second timer also. So in that case, here what we need to do, we need to make the changes into this IE register. So here in spite of 82, here the count will be 8AH. 8AH. Now why it is 8AH? Because see here, when we are using, okay, so when we are using the interrupts, we need to enable that specific interrupt. So here we can see that for timer 0 interrupt, this bit is set. Then for timer 1 also the bit is set. So when we are setting this timer 0 and timer 1 interrupt, here the bit specification will be enable all will be 1, then two other bits which are reserved bits will be 0 0, then for serial interrupt that will be 0, then timer 1 will be 1, timer 0 will be 1, and external interrupts will also be 0 0. So the count is 8AH that we need to set here, and we need to start TR0 as well as we need to start TR1 also. Okay, so here we need to write set B TR1 also. Okay, and we will start the timer. So here for using two timers, here we will set it as time 22. First one for timer 1 and one for timer 0. So here the count will be 22H. Then for TH0, here we will get one count. For TH1 also we need to write the count. So here for the sake of simplicity, we will take the same frequency at two different locations. Okay, so here for timer 0 the count is provided by TH0, and for timer 1 the count will get provided by TH1, and these two timers are getting started. So here the ISR of timer 0 will be 000BH. So here for timer 1 also we need to write the ISR as 000, which will be the location for timer 1. It is 001BH. This is the ISR location for timer 1. CPL port 2.1, and then last instruction will be RATI. So this is the process for taking two separate timer interrupts, timer 0 interrupt and timer 1 interrupt. Okay, everyone understood it? लक्षात येतं का इथं काय केलेलं आहे? जर आपल्याला दोन्ही टायमर्स वापरायचे असतील, टायमर 0 आणि टायमर 1 दोन्हीही जर वापरायचे असतील तर आपल्याला काय करायला पाहिजे? वी नीड टू सेट द टीमॉट रेजिस्टर फॉर बोथ द टायमर्स, टायमर 0 and timer 1. So here by default we have taken two timers into the auto reload mode. Okay, so the count is 22H. then we need to set the count for timer 0 also and for timer 1 also. So here we have taken one count into the TH0, and at the same time we have taken another count into the TH1. Now see here, we have taken the same count because here the frequency will be the same. But if suppose we want to set another frequency, then we need to adjust the count according to that. Okay, so we need to make the calculation, and according to that we need to set the count into the another TH1 register. Okay, and after that we have set IE as 8AH, because here the if we check the bit status of this IE, then the count becomes 8A. So here we have set the count, we have started the timer, and we are keeping the program into the loop. Okay, so we'll check here what will happen. Now here we have taken 2 ports, so I will take 2 ports here. Okay. Then for logic analyzer, here we will set one is port, another is port 2.1. So here we will check the status now. Now see here, you can get 2 frequencies here, or 2 square wave at 2 different port pins, port 1.1 and port 2.1. You can check the status here also, port 1.1 and here port 2.1. Okay, so everyone understood it. So we can use timer interrupts into for programming or to generate the delay. Everyone understood it?